All right, everybody, my name is Ryan. Welcome to my channel. So today I want to talk about mall tenant mix optimization, and the goal here is to try to maximize foot traffic and sales as well. Okay, so these two kind of go together. More foot traffic, more sales. More sales comes from more foot traffic, right? So in the last couple of days, I've been doing a few of these optimization models. I like these a lot. You're just looking at a basic scenario, right? Usually some type of business operation, whatever the case is, and you take the normal business and try to optimize it so it runs more efficiently, right? So today I want to look at how to maximize mall tenant optimization based on square footage for the type of store that you lease out or that you own if you're the owner, and the mix of um, outlets in the mall, right? So you could have a couple of coffee shops, maybe multiple coffee shops, some restaurants, what else? Like a couple of anchor stores, maybe a grocery store or something like that. We want to see how the mix is going to shake out and what's the optimal allocation of different types of businesses in the mall. Okay, this is why we do this type of analysis to understand what's there right now, or I mean, what's there on that we're planning for. And as we're doing the planning, try to optimize it. I'm not saying like it's in place right now, or maybe it is, right? Maybe you have something in place right now that is suboptimal and you need to optimize it. But I'm just thinking about this scenario as a new mall that's being developed and being planned. How do we optimize this on paper before we execute and start the construction? So mall owners typically want to rent a function as sales per square foot, right? That's the metric that they focus on. Better tenant mix drives higher sales increases, higher rental income, higher property valuation, and higher investor returns, right? So win-win-win across the board. And even small lifts and portfolio level sales can translate to large net operating income, NOI, or ROI, return on income. Okay, so we want to look at the right combination of anchors, fashion, dining, entertainment, maybe there's a movie theater, maybe there's an arcade, right? What kind of destination effect can we create for our customers, right? When we optimize these things, it's going to attract more vendors, more visitors. The vendors are going to stay longer, right? And encourage multi-store visits, right? You want repeat business. You don't want the customer to come into your store, spend some money once, leave, and never return, right? You want to build a relationship and have a rapport with the customer so they come back over and over again. So that is the goal here, and I'm going to show you how to set this up and how to execute on this plan. I have a couple of other notes here. You can read that at your leisure. I'm not going to spoon feed this to everybody. It's right there, right in front of you. You can just read that, okay? So I'm going to go ahead and create a scenario where I have some sample data. Now, I don't have an actual retail mall um, data set or plan. I looked for this online. I didn't really find anything. I'm sure these things exist. They're probably highly proprietary and very personal or somewhat secretive, right? So I'm not going to have access to this stuff, but I can certainly appreciate what this would look like. I've been to several malls. I've seen the layout. I know how they function. So I'm going to create a synthetic data set that's going to be very realistic and representative of an actual mall. So no, I don't have the actual mall data. Only the mall owners are going to have that. Maybe the construction business might have that. I don't know, but I don't. But I can simulate that pretty easily. So we have a few types of stores here: anchors. We're gonna have some fashion outlets, beauty, jewelry, cafe. There's probably gonna be some vacancy, right? For it to be 100% occupied would be rare. That would be great, right? As the mall owner or as the small business owner that rents this property, that'd be great. But realistically, probably you're gonna have some vacancies. So I'm gonna account for that between 800 and 4,000 square feet. That's what I'm gonna say. And for the anchor stores, these guys are gonna be pretty large, right? About 80,000 to 160,000 square feet, and you have everything in between. So let me go ahead and run this right now. Control Enter to run it. And as the code runs, I'm going to go ahead and populate this data set with the stores that I think are representative of what we would see in this type of setup, right? When we're planning how to put together this mall, what kind of stores would we see in these different places, right? So I'm going to create a dictionary. You can tell by the curly braces and the key value pair. This is the key. These are the values. This is what would probably be the makeup of a department anchor store, right? This would be the makeup of a department. I'm sorry, not department for a mall department store. It said department or something. I don't know what I said. So for a mall department, sorry, I just said again. Oh, I'm looking at department. Sorry, guys. Whatever. So for a mall anchor store, forget about department. This is probably the makeup, right? For a more mall sports store, it's probably going to be one of these guys. For a mall cafe, probably one of these guys, right? These are the usual suspects. So you can appreciate how that works. So this is what it looks like when we print this out. So we have tenant names over here. Dunkin', it used to be called Dunkin' Donuts. They dropped the donuts. I guess it was too confusing or too hard for people to say donuts. So now it's just Dunkin'. We have Chipotle, the category of the store, zone level, and then square footage, right? So again, I don't have this data, but I can make synthetic data that is highly realistic to what the actual data would be if I actually had that data, okay? So control enter to refresh this. So we have the tenants and the categories and the square footage above. I'm going to start to assign um, different levels to these stores. And then based on these categories right here, I am going to go ahead and start to um, fill out like what the default setup would be like, okay, in terms of like how popular these stores are, the foot traffic, how much business can we expect, based on the style of the store, right, in this mall. So whether it's a anchor department, grocery store, beauty, jewelry, entertainment, casual, right? Like what kind of foot traffic can we expect? Higher, lower, and in between, things like that. So we have to generate this data. Is this an anchor store? Yes or no? What size is the square footage overall, right? Based on the style of store. So anchor is going to be pretty huge. Cafe is going to be pretty tiny, right? These are just common sense things. So we're going to go ahead and just create the setup and then fill in all the data points right there. Okay, now I do have to create a couple of functions. This is a user-defined function. Some people call it UDF, right? So we have expected sales for units. So we're going to go through different rows and add in these category parameters to, again, to fill in all these data points that I need to populate so I can consume that for the analysis, which comes below, okay? So we have the overall portfolio KPIs. Again, these are key performance indicators, and we want to just take a quick look at this to understand how are these stores actually performing, right? KPIs is a performance indicator. And this is a very common business metric to understand. Is the store performing at expectations, maybe below expectations, maybe above expectations, right? We have to know how the store is doing. We don't just set it up and just let it run wild. We have to have some kind of metric to understand it's successful or not successful or somewhere in between, right? So we set that up and run it, and we have overall sales right here, sales per square foot, overall foot traffic, vacancy rate. So pretty tiny, but not totally vacant, right? So vacancy and then spillover uplift percentage. Okay, so these are the types of things that we know that we're getting just off the shelf here, just baseline or just no special treatment. This is um, what we're starting with right here. Okay, so this is kind of what we're going to expect based on other malls and other historical, um, you know, how these things have been set up and planned in the past. But we're going to try to optimize it in this scenario, right? To lift everything up and to maximize the performance of each store in the mall, right? Again, we're trying to improve foot traffic and sales. That is the goal here today. So we are going to go ahead and set our baseline over here. So based on the category, and as long as this is not vacant, what kind of square footage can we expect? Just baseline. This is just without without any uplift, without any special treatment, or without any kind of optimization. This is how the mall would perform. Just the standard run-of-the-mill mall. Okay, so we have a couple different minimum and maximum counts that we're going to have. Again, these are just hypotheticals set up to be realistic, and we need something to populate our data set with, or our data frame with, and we're going to feed that into the optimization model and then run the optimization based on that. Okay, so I think I just ran this. Let me do it again to make sure. Okay, so we have all the data points filled in, right? We have the mins, the max, the averages, the counts. These are all baseline scenarios, right? So very, very basic. Nothing special has been done at this point. But again, we're going to set this up and then start to do the optimization. So down here, we have the basic units. We're copying this to optimized units. So you'll see this in along my videos. I have the basic data frame over here. If you see this, usually I just kind of race through these things because I give you guys all the code and I can't sit here and explain like every nuance and every detail of everything that goes on because it would take hours and hours, right, to get through the video. I don't think anybody's going to sit through that. So I kind of like cruise through it pretty fast. But some things I do have to take a moment and pause and just explain. So this units comes from back here. Units actually comes from all the way back over here, going back, going back, going back. Units. Oh, let me just go to the beginning. Wow, it's all over the place then. Probably should have given this a more deliberate name, but that's okay. So we really see units over here. Yeah, okay, so that's the original data frame, right? So we take this and it kind of cascades all the way down, all the way down, all the way down to the bottom. And the reason I'm showing you this, whoops, I just lost it now. Let me go back there. The reason I'm showing you this is because I found um, it's pretty nice and pretty efficient and I think pretty professional too to take the data frame that you're using and then create a copy based on that. So I'm taking the original data frame and copying that into a new data frame so I can do some operations on that. And the reason I do this, okay, is a very specific purpose. If something gets messed up as I'm developing the code over here, I don't want to go all the way back to the original units I just showed you. It's a little bit hard to find. There's a lot of code here. It gets buried pretty quick. But if I create a copy and if this units underscore bad gets messed up, I only have to go back here. I don't have to go all the way back to the beginning and redo everything, right? So when I develop the code and debug it and put all this stuff together, I found that it's a lot easier to take something that I know works because I've seen it working above. I know it's fine up to this point, create a copy from that, and based on the copy, I'm making modifications and updates, and I'm altering this data, right? But I'm not altering the original. If I did that and this mistake here, again, I have to go all the way back and then redo everything all over again. Just wastes a lot of time. It gets very confusing. Now, if there's an issue right here with units bad, I only have to start here and down, fix the issue. I don't have to go right back to the beginning and redo everything. So that I thought that was worth a mention. So here's the baseline KPIs: total sales, sales per square foot, traffic, vacancy rate, and then spillover, uplift percent. And again, that's what we're trying to optimize right here. The spillover uplift is going to be uplifting all the store's performance, right? So foot traffic and sales based on the combinations of stores, right? And the layout and the placement of all these stores. What level are they located? Who's located next to who? You know, after you get these two guys set up, who's the next one in line and who's the next one, right? So we want a certain like flow through the whole mall. We want it to flow so people, okay, I'm looking for fashion and I'm looking for jewelry and maybe like a fast fashion and then maybe like a high end, like super high end expensive outfitter, right? So these guys will kind of go together. You don't have like fashion next to a Starbucks and then that's next to like who knows what, like a gym or something like that. That doesn't make a whole lot of sense. You want to flow, right? And if these stores are not positioned in an efficient way, in an optimized way, that's what this model is going to do. It's going to look at different possible traffic outcomes or outputs, right? Based on how the stores are aligned, and it's going to align the stores in different ways, right? And see what the potential traffic is going to be for the optimized scenario. That's what we're doing here. So let me go ahead and hit Control Enter to refresh the data here. So we have the data frame and the summaries right here. So we have the original category and the optimized category right next to that. In this view right here, the baseline and the optimized were pretty close. So I think the original layout was pretty close. Things were working. In the next view here, we can see the scenario is baseline optimized. So total sales did increase, right, from 153K to 246 after we've optimized this. So that's an improvement. The original layout of the stores or categories of stores that will exist in this mall. It's not actually low. It's a category of the store. The baseline and the optimized really didn't change based on what I'm seeing here. It looks the same, but the total sales did get a boost. Sales per square foot, obviously that's going to change because square footage doesn't change. Traffic stays just about the same. So actually people just spend more money here in the optimized scenario. Don't really create more foot traffic. And vacancy rate actually jumped up a little bit in the optimized scenario. And the spillover uplift percent actually decreased a little bit. But the model went through all these scenarios and it actually found out that total sales will increase. Presumably, people spend more time or just more money because they have this perceived sense of satisfaction in the mall. So sales increase, sales per square foot increase, traffic doesn't change. Vacancy actually went down a little bit, and the spillover effects actually dropped just a fraction. And that's okay. That's okay. So let me look at one more view down here. Control Enter. I'm going to create 3 charts to see the before and after. So baseline was was the original scenario we set up. So 153K spent. So this is per day on average, right? So the units is in US dollars and the time frequency is 1 day. In the optimized scenario, 246, right? So there's the uplift. Sales per square foot originally 0.26, 0.41 in the optimized scenario. And here we see the baseline and the optimized were kind of the same over here. There's not a huge lift, and we kind of saw that over here too. We saw the counts, right? So the baseline and the optimized were kind of the same, and we see the outputs over here. So the real benefit to doing the optimization here was sales per square foot and overall sales, right? You can see per square foot per day, and overall sales jumped almost 100K, right? Like I'm looking at 4653, maybe 93,000 per day on average because of the optimization. Okay, so this didn't really change. Baseline and optimized was the same in terms of the counts over here that we saw, or the categories. Not the counts, the categories, baseline and optimized. But the sales did improve. Okay, so I think the model is working, and I think we had a positive outcome here. So that is one scenario. And guys, trust me, there's probably a few different ways to do this. This is one way. I'm not saying this is the holy gospel. I'm not saying this is the only thing out there. But definitely, you can see that this works, and this is one way to do it. There's probably a few different ways to skin this cat. This would be my approach. I'd love to hear your feedback. You tell me, what do you think? Does this work? Does this make sense to you? Would you use a different approach, a different optimizer, or just a totally different technique? Maybe instead of optimization, we could try some type of heuristic. Maybe that would be another approach, a different perspective on that, right? But definitely works. And I just want to share my findings with you. I think this is pretty interesting, and I want to put it out there. So let me save the code. I'll share all the code with you guys, like I do with all these videos. Every time I put together the code and put a video on YouTube, I always share all the code. So you have the source code that I used when I created all these charts and graphs and all the analysis, right? I think that's a great way to learn. You can copy and paste this into your own Jupyter Notebook environment and run it, and you'll get exactly the same thing that I see here, right? These are called deterministic. You know what's going to happen before it happens. But if you want to change the code and play around with it, fiddle with it, try to improve it, break it, fix it, put it back together again, by all means do so, okay? I'll share the code with you. You can do whatever you want with it. So that's it. That's my take on mall tenant MEX optimization. How do we arrange these stores? And what is the types of stores that we are optimizing for too, right? So I think that is that's pretty interesting too. So, well, actually, you know what? I'm actually going to redo this. I'm going to stop the kernel, restart the kernel, and do one more run, because every time the optimizer is going to run potentially a little differently, right? Because it's kind of a random process, at least to start, right? It has to start randomly, and then it goes and it tries to pick the best scenario. So let me try one more time to run this. Run all above selected cell and see what this comes up with. Right? Let's just check out these charts. All right, when it comes up with this thing at the end and see what this thing looks like. Is it done already? Oh, almost. It's pretty fast. Okay. We always have to start with a random scenario, and that's how the lottery works too. If you're curious, like it always starts with a random seed. These are called random seeds, and then it goes ahead and does the analysis. Not the lottery. I mean, the lottery is randomized too, but with these optimizers, it creates a random start and then solves for the optimal solution, right? So in this case, when I reran it originally, we had like a different output here. 50 cafes. I can pretty much guarantee you that is way too many cafes for a mall, right? Maybe you'll have a handful. The optimized solution here came up with 10. That sounds like a little bit much, but definitely you can have Dunkin' Donuts, a Starbucks, couple others, small mom and pop shops, maybe smaller chains, right, like that. The model came up with 10 cafes. Sounds a little bit high, but that's so plausible. Definitely better than 50. Here, originally, the count was 5 beauty salons or beauty types, Sephora, things like that, right? They said the optimized count was 12. One anchor grocery store, department anchor, that makes sense. Electronics, the original was 7. The updated was 9, right? Home store, no, I don't know what that means. Like Kohl's or something. They have to look into that. Casual, sports, but you can see how it works, right? You start with a baseline number, and when the optimizer runs, it says, hey guys, this is not optimal, this is suboptimal, so we need to fix it. And that's what the optimizer does, right? So it did its job. Okay, so that's it. I didn't change any code. I just killed the kernel and restarted that. So nothing changed in the code. I'll share that code with you guys when I post a video. I'll drop that later today. And I've got a couple more on the back burner. I'll take those out and start working on those, get those refined a little bit and ready to go. And I'll drop a couple more videos in the next couple days. So keep an eye out for that. Thanks, guys. And that's it for this one. And I'll see you in the next one. Okay, goodbye for now.